Today we're going to talk about how we reduce radicals, as well as other operations with radicals, such as adding, subtracting, and multiplying. We'll talk about dividing tomorrow. So first I'm going to do a little bit of review, because we've already talked about how to reduce square roots back in our quadratics unit. So if I have the square root of 75, I'm going to make a factor tree for 75. And I'm looking for pairs of numbers. And when I have a pair of 5s, 1 5 will come outside my root, and the 3 that doesn't have a pair will stay inside my root. So if I was reducing the square root of 75, the reduced version would be 5 root 3. Now, in this lesson, we're going to talk about how we reduce radicals that are not just square roots, and also what we do when there are variables involved. So, the first thing we need to talk about is the number that is in front of our square root is called our index, that little number. Now, if there's no index, then we assume that that's the principal square root, meaning the index is 2. So if we look at the first example, I have 48. And I have the fourth root of 48. So the first thing I'm going to do is do just like what we did with square roots, and I'm going to break down this fourth root of 48 into its prime factors. Now, this is a fourth root. So just like with a square root, how I look for pairs, in a fourth root, I'm looking for 4 of the same number. So in this case, I'm going to have 1, 2, 3, 4 2s. So since I have one group of 4 2s, the 2 is going to come on the outside. Now, I have the fourth root still because I have a 3 that's still going to be left on the inside. So the index tells us how many we are looking for in terms of that pair or group. When I look at example 2, I'm going to do the same thing, except for now I have a negative involved. When we have a negative, we can only deal with negatives underneath an odd index. We cannot take the cube root of the square root or the fourth root of a negative number. So actually the first thing I'm going to do is I'm going to break this into the cubed root of -1 times the cube root of 875. Now the cubed root of -1 is just -1. So I know that a -1 is going to come outside my root. Now I'm going to break down 875. So I know that it's divisible by 5, and then be 5 times 175. 175 is also divisible by 5. 35 is also divisible by 5. So now, this is a cube root, or the index is a 3. So that means I'm looking for a group of 3 of the same number. So I have 3 5s. So that means a 5 is going to be outside the root, and the 7 is going to stay inside the cube root. But don't forget that I already pulled out a -1. So I have to do -1 times that 5. So my final answer will be -5 cube root of 7. So now we're going to look at reducing radicals where there's variables involved. So if we look at example 3, I have the 6th root of 256, x to the 20th, and y to the 6th. So the first thing I'm going to do is I'm going to break down the 256. And again, I'm looking for 6 of the same number. So 2 divides 256, and I get 128. 2 divides 128. 2 divides 64. 2 divides 32. 16 I'm going to break into 4 and 4, which will give me 2 and 2 and 2 and 2. All right, that's a lot of 2's. So I have 1, 2, 3, 4, 5, 6, 7, 8 2's. So I'm going to circle 6 of them. So there's 4, 5, 6. So I know that one of my 2's is going to come outside the root. I'm going to leave a little bit of space for my variables. And I know that 2 2's are going to stay in the root. So if I re-multiply those back together, I'm going to have a 4 on the inside. Now, I have to do the same idea with my variables. So when I look at my variables, I have 20 x's. So if I were to write that out, I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so I have 20 x's and I'm looking for groups of 6, and I kind of purposely put them in their groups. So I have 1 group of 6, 2 groups of 6, 3 groups of 6, with 2 left over. So that means an x to the third is going to come outside my root, and an x squared is going to stay in my root. Now if I do the same thing for the y's, I have 6 y's, so 1, 2, 3, 4, 5, 6. Well, that's going to give me exactly 1 group of 6, so 1 y comes out, and I would have no y's left on the inside. So this would be my final answer. I'd like you to pause the video now and try example 4. Remember, whatever you pull out from under the root is going to get multiplied by this -3. So pause the video now, give number 4 a try, and play the video to see if you did it right. All right, let's see how we did. So the first thing I did was I broke down the 448. I found out that I had 6 2's. So that means 2 2's are going to come out because I have 2 pairs or 2 groups of 3. Plus I already have the -3 on the outside. So on the outside I have -3, 2, and 2. Then I looked at the variables. Well, I had 8 x's. 8 x's means I'm going to have 2 groups of 3, so I get x squared. And then I have 2 left, which is also going to give me x squared. So I'm going to have an x squared on the outside and an x squared on the inside. So that's where these come from. Now, I only have 2 y's, and I need 3 in order for them to come outside the root. So both of those y's stayed on the inside, so I had a y squared on the inside. Then I multiplied my numbers together, so I got -12x squared, cube root of 7x squared, y squared. All right, now we're going to look at operations with radicals. First, we're going to look at multiplying. So if we look at our rule at the top, when we multiply 2 radicals that have the same index, we can really just multiply them and put them under 1 index. So if I look at example 1, I'm going to combine this and put it all under 1 index. So I'm going to have the cube root of, well, 50 times 15 is 750. Now keep in mind that when you multiply variables, you add the exponents. So I have an x squared. I don't have any other x's, so I'm going to have x squared. I have a y cubed. And I have a z5 and a z1, which means I have z6. So now that I've multiplied these together, though, I need to simplify this radical like we did earlier. So I'm going to break down my 750, and I already know that it breaks down into 50 and 15 because I just multiplied those numbers to get me the 750. Now, it's a cube root, so I'm looking for groups of 3. So I have 1, 2, 3 5s. Perfect. So a 5 is going to come on the outside. I'm going to leave some space, cube root. I have a 2 left over, and a 3 left over, so that's going to multiply those back together. So I'm going to have a 6 on the inside. Now I'm going to look at my variables. Well, I have an x squared. That means I don't have enough for a group of 3, so my x squared is going to stay on the inside. I have a y cubed. Well, a y cubed means I have 3 y's. So that means I have 1 group of 3, so I'm going to have 1 y on the outside and no y's left over on the inside. Then I have z6. Well, z6 means I have 2 groups of 3. So I'll have a z squared on the outside and no z's left on the inside. And so this is what my final answer would look like. Now I'd like you to try 2. 2 is really similar. We're going to multiply together and then reduce. Remember, when you're multiplying, you're also going to multiply these outside numbers. So I'm going to start off having a 14 on the outside, and then whatever I have on the inside, and then reduce. Pause the video now, give it a try, play it when you're done. So the first thing I did was I multiplied them together, and I got 14 on the outside, and I got 18x cubed y cubed on the inside. Then I broke down the 18. The 18 breaks down into 9 and 2, and then 3 and 3. Since I have a pair of 3's, the 3 came out with the 14. Then I looked at my variables. Well, I have an x cubed, so that's 3 x's. This is a principal root, so I'm looking for a pair. So I have a pair of x's, so 1x came out and 1x stayed in. Same with the y, I have 3 y's, so a pair comes out, 1 stays in, so I have y, y. And then when I simplify my answer, I'll get 42xy square root of 2xy. When we add and subtract radicals, similar to when we multiply radicals, we can only multiply radicals if they have the same index. When we add radicals, they have to have the same index and the same radicand. A radicand is what's inside the radical, or what's inside the root. So if I look at example 3, I have the same index, they're both square roots, and I have the same thing in the root, which is a 5x. So if I did 3 root 5x minus 2 root 5x, I would get 1 root 5x, or just square root of 5x. If I look at example 4, they look like they're the same, but this one's a cube root and this one's a square root. So this one's not possible. Or you could also say it's fully simplified, because there's nothing more that we can do. When we look at example 5 and 6, we can see that these aren't the same, so your instinct is to write, again, not possible or fully simplified. But in fact, these are not fully simplified, because each of these radicals, the 12 and the 75, not the 3 because he's prime, but those can be simplified. Once I simplify those radicals, I bet that I can add them together. So if I simplify the 12, I'm going to get a 2 on the outside and a 3 on the inside. If I simplify the 75, I'm going to get a 5 on the outside and a 3 on the inside. Well, now all my roots and all the numbers underneath my root are the same, so now I can add and subtract. So I'm going to do 2 plus 5 minus 1, so I'm going to get 6 root 3. Go ahead and try example 6. Same idea as example 5. Simplify each of your radicals based on the fact that they're a cube root, and then add the ones that have the same number underneath the root. When you're done, play the video to see if you got it right. So if I simplified each of my radicals, cube root of 250 will reduce to 5 cube root of 2. Cube root of 54 will reduce to 3 cube root of 2. And cube root of 16 will reduce to 2 cube root of 2. So then I can do 5 plus 3 minus 2 because all of my radicals are the same, and I'll get 6 cube root 2. All right, now we're going to put it all together. So if I look at example 7, I have a radical outside and some parentheses. Well, if this didn't have radicals, I would distribute. So I'm going to do the same thing, distribute the root 6 in. Now, I can only multiply root numbers with root numbers. So when I multiply the root 6 in, I'm going to do root 6 times root 3. The 7 is just going to stay on the outside. So I'm going to get 7 square root 18. Now, I have root 6 times 6. Well, that does not become root 36 because root 6 is a root number and 6 is a non-root number. So I'm just going to get 6 root 6. Now, make sure you always fully simplify. My root 18 can actually be reduced, and it'll become 21 root 2. Now in this case, I can't add those because they're not the same, but sometimes I'll be able to, so I have to make sure that I always fully simplify my roots. All right, using your algebra skills, I want you to try 8, 9, and 10. You're using your FOIL and your distribution. Remember, only multiply the like parts. Multiply outside numbers or multiply inside numbers. Pause the video now, try 8, 9, and 10, play the video and see if you got them right. All right, let's see how we did. So in number 8, when I distribute the 3 into the parentheses, I get 6 plus 12 root 5. Then when I distribute 2 root 5 in, I get 4 root 5 plus 8 root 25, because I have to multiply the outsides and multiply the insides. So I can combine the like terms of the 12 root 5 and the 4 root 5, and I'm going to get 16 root 5. Then square root of 25, well, that's the same as 5. So I really have 8 times 5, which is 40. 40 plus 6 is 46, so I get 46 plus 16 root 5. Number 9, don't be tricked. When you have something squared, you have to write it 2 times. So I wrote it twice and then I FOILed. So I did 2 root 3 times 2 root 3 and I get 4 root 9. 2 root 3 times negative 5, I get negative 10 root 3. Negative 5 times 2 root 3 is negative 10 root 3. And then negative 5 times negative 5 is positive 25. Again, I have a perfect square here. Square root of 9 is 3. So this ends up being a 12. I combine my like terms of negative 10 root 3 and negative 10 root 3 to get negative 20 root 3. So I end up with 37 minus 20 root 3. Now the last one is very similar to 8 and 9. So I distribute the root 6, I distribute the 4 root 5, and then I get 4 roots that are not at all the same. So I go and simplify each of those roots. So I simplify the square root of 18, I simplify the square root of 60. The square root of 15 actually couldn't be reduced. I tried, so I left that one the same. And then I reduced the square root of 50. Once I reduced each of those radicals, then I had some like terms I could combine. I could combine the 12 root 2 and the negative 20 root 2 to get negative 8 root 2. And then I combined the negative 2 root 15 and the 16 root 15 to get 14 root 15.